like many of the firms in the sustainable or green industry, Cree actually was founded in 1987. So we've been around quite a number of years. We were founded by a group of graduate students out of North Carolina State University in Raleigh. Interestingly enough, we were originally based, the business was originally based on government contracts. So we were not really a commercial entity at the beginning. As we developed the technology over a number of years, we began to become more of a commercially focused company. We're a bit different than most of the semiconductor companies that you know, in that we build 100% of our LED chips in Durham, North Carolina, and we sell most of them in Asia. So we're a little bit backwards to most of the companies in the world. We are a company that's based on U.S. innovation. However, we are a global company. We have a number of locations around the world. The first commercial LED application that Cree was able to take advantage of, and maybe many of you have experienced this, those blue dashboard lights on a Volkswagen, that actually was the first commercial large volume customer for us. Cree invented the blue LED, which is very important when you're talking about making white light, because without a blue LED you can't make white light. We not only invented it, we continue to still make the best ones. From that early business making chips, LED chips for Volkswagen dashboards, we became a major supplier of LED chips really for the portable consumer electronics business. Many of you may not know, but the keys and the screen on your cell phone are actually illuminated with LED chips. The screen on your iPod. If you have a new MacBook, the screen on your PC. If you are a television aficionado and you go to buy a new 47-inch LG LCD television, the screen behind that is actually illuminated with LEDs. What you'll find is that the benefit of that is it takes a contrast ratio from about 20,000 to about 1 million. Phenomenal improvement in capacity, or in quality. So we started out making LED chips, consumer electronics based, which of course meant we were susceptible to the business cycle for, what the cell phone market looks like if you follow the major providers there. But as the technology advanced, which means LEDs got brighter and brighter and brighter, they are a semiconductor device, so similar to the processors in your PC or the memory chips, they continue to get better and better and better every year. As we began to improve the performance of the technology, we realized we could move from lighting cell phones or other small consumer applications to actually doing general lighting, really replacing the light bulb. The LED technology has advanced dramatically over the past couple of years. We've gone from being effectively a little more efficient than a standard light bulb to being among the most efficient lighting technologies available in the world today. And we're not finished. We're going to continue to get better and better and better. So as we've realized this opportunity for general lighting, we've started to transform the company. Being a manufacturer of semiconductor chips is very different than being a lighting supplier. Essentially, semiconductor manufacturers have a dozen or so customers, probably all in Asia. Lighting manufacturers or lighting component manufacturers have thousands, if not tens of thousands of customers around the world. So it's fundamentally changed our business model. Jackie mentioned that I've been at Cree for about 3 years. That's because Cree's only really been doing marketing for a little over 3 years. Because when you're a semiconductor company, you don't really need to do marketing. You have 15 customers, you know who they are. They know who you are. But once you start to address a broader, larger market, you need to add some more capability. A little bit about LEDs. How many people here are familiar with LED technology? All right. How many people here have heard of Cree before? All right. I'm the marketing guy. That's a good thing. So this increase in performance of LED technology, just to put it in perspective, an LED component today is effectively about 80 to 90% more efficient than a standard incandescent light bulb. We're also up to 50% more efficient than a compact fluorescent. Now we're becoming more efficient even than linear fluorescents, which are among the most fluorescent lighting technologies available. Not only are we more efficient, we last more than 50 times longer than a standard incandescent light bulb, and more than 5 times longer than a compact fluorescent. The durability and the life cycle of the product is important in a number of ways. One is you don't have to incur the labor and the cost of changing them, but you also don't have to throw them away or dispose of them. So you're going to end up with the landfill impacts. In addition, LEDs don't contain any mercury, lead, or other hazardous substances, which is a big factor, we believe. I think hopefully some of you have seen that Cree's mission statement is that we intend to obsolete the energy efficient light bulb. And some people say, well, which ones? All of them. We believe it's just a matter of when, not a matter of if, that LEDs will replace traditional lighting technologies. Now, having said that, it's not as easy as it sounds. The lighting industry is over 100 years old. They haven't adopted a lot of technologies. The fluorescent light bulb was invented right after the turn of the 19th century. The incandescent bulb was invented in the 18th century. Now, there have been a lot of technologies invented or implemented around the light sources, and there have been some new light sources. But effectively, you have an industry that's been focused on taking a light bulb and putting something around it and hooking it up to the electrical system. When you start to embrace LED technology, you now have the need to deal with printed circuit board manufacturing, solid-state power supplies, thermal engineering, kinds of things that you didn't have to worry about before. So it is a industry revolution that we're embarking upon. We call it the LED lighting revolution. And maybe you know who Tom Friedman is. He spoke at a conference in Raleigh, North Carolina last year. And his point was, a lot of people say we're in a green revolution. He says, we're not in a revolution, we're in a green party. Because in a revolution, people get hurt. And we fully intend to hurt somebody. Having said that, we're in a bit of a fortunate position that we are in a perfect storm in some respects. I talked about the improvement in the technology over the last few years. What that means is that it's now, it's been possible to make lights out of LEDs for a number of years. It's now economically viable to make them and sell them. So the technology improvements help the economics. Anybody in here's electricity bill getting cheaper? Oh, we got one guy in the back. All right. You must be using a lot less. Electricity rates aren't going down. They're going up dramatically around the world. Not just here in the U.S. In fact, the U.S. still has very cheap electrical power. At the same time, as most of you are aware, the political environment for sustainable technologies and energy efficiency is perhaps more favorable today than it's been for quite a while. So what kind of impact are we talking about with LED lighting? Anybody know how much of the electricity in this country is used for lighting? About 22%. In fact, in a building, it's usually over 30%. In a retail store, it's more like 60%. It's a very big component of our electrical usage. The U.S. Department of Energy has estimated that between now and 2025, the widespread deployment of LED technology can save U.S. consumers about $280 billion in electrical charges, eliminate 258 million metric tons of greenhouse gases, and also displace the need to build over 130 power plants. It's a significant impact. In fact, we think it potentially one of the biggest impacts of any commercially available technology out there today. Let me show a couple pictures now. So, from what I've just said, it sounds like, well, this is a great thing. It's going to happen. How come it's not going faster? There are a lot of naysayers out there. The same naysayers who said, I'm never getting rid of my record albums. I'm never going to stop using film. Why would I get rid of my TV? It works perfectly fine. Some of you in here may even remember vacuum tubes. Many of you may not. We actually talked about the light bulb. The light bulb is the last vacuum tube. So we're in the process of replacing that as well. So how have we done? We've essentially reoriented the company from a semiconductor manufacturer to a lighting component and a lighting product supply company. Here's a little view of our quarterly revenues since the middle of '07. It's been quite successful. So not only has our revenue gone up, but if you look over here on the right side of the chart, in the third quarter of '07, we essentially were a chips company. We sold a few other components, but we were a chips company. If you now look at the first quarter of this year, we're now primarily an LED components company. And that is the fastest growing part of the business. That part of the business has been growing at double digits every quarter for the last 8 quarters. What does that mean for the number of people that we employ? You can see the accompanying growth in our employment. I want to make a comment about employment as well. That's Cree's impact on the number of people that work for Cree. There's also a very significant supply chain impact associated with the change to LED lighting. The designers, the engineers, the contractors, the distributors, the agents who are all supplying this lighting, especially in the case for retrofit, they wouldn't be supplying lighting otherwise. So there are a number of job impacts beyond just Cree, but also into the supply chain. So let's look at a couple of examples. This is a roadway tunnel in Italy that one of our customers actually supplied lighting for. This is the before picture, and that's the after picture. That lighting, which you could argue is significantly better quality, uses 61% less electricity. Given the rates that they pay in Italy, that's less than a 3-year payback, and that's a retrofit. On a new tunnel, the payback is almost immediate. This is a building some of you may be familiar with, the United States Pentagon. This is a room beforehand, 432 watts in the ceiling, and afterwards 288 watts. Now this screen's not the best resolution, so I'll point out a couple things. Look at the shelves, and look at the tops of the walls, and look at the improvement in the lighting distribution. If the screen were a little better quality, you could also see that in this picture before, you can't see the red in that floor. And after, you can see the red in the floor. One of the advantages to well-done LED lighting as opposed to fluorescent lighting is the ability to show colors is significantly improved. We were saying earlier before the session, you'll never eat in a steak restaurant with a fluorescent light over your table. Because fluorescent lights don't show red very well. And when someone brings you your rare, medium rare steak, you're going to go, I'm not eating that. So we believe you don't have to make any compromises. You don't have to go from high quality lighting to energy efficient lighting. You can go from high quality inefficient lighting to high quality efficient lighting. Anchorage, Alaska is in the middle of replacing all 16,000 of their streetlights with LEDs, saving them over $1.5 million a year. We were talking about hospitality earlier. The businesses in this country and other countries that continue to use incandescent and halogen lighting, even though they know how inefficient it is and how often they have to replace it, are restaurants, hotels, retail, any place where the appearance of the people and the products and the services is very important to them. This is Sheraton Hotel in Greensboro, North Carolina. It's putting over 2,000 LED recessed lights in. As you can see, some of the ceilings are high, which means they're not easy to change. So they're going from a product that they have to change every 1,000 hours to a product they don't have to change for over 50,000 hours. And they're saving up to 82% on their electricity. There's a gas station in Kentucky that did all of the external lighting with LEDs. As you can see, very high quality lighting, 62% energy savings. This is one of my favorites. Local university, NC State. This is the Dan Allen parking deck. And by the way, the photography is not photoshopped. The levels are all zeroed, so we're not cheating. This is what it essentially looked like before, and this is what it looks like after, using 27% less electricity. The interesting thing now is you can't find a parking space in this deck because the students all want to park here, not in the other decks, especially the girls who don't want to walk into that dingy, dark parking lot after dark. You also can notice, you can tell what color the cars are. So you remember that color rendering, color rendition I talked about? Very important here. Ann Arbor, Michigan's in the middle of replacing all of their downtown post-mounted fixtures. Any engineers in the room? What's unique about that picture? I don't have to be an engineer, but I like to pick on the engineers because if they can't figure it out, it's really...
Near the lights. The snow didn't melt?
The snow didn't melt on the street light. LEDs put out much less heat than other technologies, which is sort of what goes hand in hand with being very efficient. Unmelted snow. Friendly's Restaurant, Massachusetts. The top picture is using 5,345 watts. The bottom picture is using 938 watts. Dorm at NC State, 60% energy saving. The other great thing about LED lights is they're dimmable. So they replace the fluorescence in this student housing with LED lights. The students love it. They don't buzz, and they can dim them, which is very, very nice. New Raleigh parking deck for their convention center, 49% less energy than existing technology. Their payback was just over 3 years. And like many municipalities, they had to do a life cycle study over 15 years. $636,000 less expensive to use LED lighting than the traditional lighting. And that's all I have. Thank you very much.